Continue on with our polynomials, the proper form, the degree, leading coefficients, identifying if they're odd or even in the graph, and if their leading coefficient is positive or negative. So we have our I can statements. I can write polynomials in proper form. We've done that. I can identify the degree of a polynomial. We've done that from the by putting them in proper form, having the actual formula. I can identify the leading coefficient of a polynomial. You can determine the leading coefficient once it is in a proper form. You can identify odd and even functions from a graph. You can identify if the leading coefficient of a polynomial graph is positive or negative. Okay, we do all of that by looking at the ends of the graph. So we still have our I will statements. We will continue to have I will identify a polynomial. Okay, today I will describe the end behavior of functions. Now tomorrow we will hit on evaluating functions. Now if we link what we know from yesterday, okay, both ends are going in the same direction. So in black, I'm going to put that this is an even function. Okay, we don't know if it's x to the 4th, x to the 6th. We don't know what it is. All we know is we have an even function. Why do we know we have an even function? Because of both of the ends of the graph are going up. Now, if we are specifically, and let me do this in red, describing, we are describing the end behavior. Okay, we're specifically describing the end behavior. Now, I wanted you to know that this is, remind you, not to know, but remind you both ends are going in the same direction, so this is an even function. Let me kind of scoot this over just a little bit. There we go. And that way I can look at this one too. This one right here is going in two separate directions, so this one here would be an odd function. And again, this really doesn't have any relevance to describe the end behavior. We're just applying our knowledge, what we knew from, learned yesterday. Now, the end behavior, both of these are going up. So when we describe, we use an arrow notation. We talk about what happens to the function as x is approaching negative infinity or infinity. So we always read left to right. That's how we read, left to right. So while we're doing this, we're reading left to right. So the first thing, and I'm going to do this in green, my function value goes to, and we're reading. On the left, which direction is that going? I'm going up and 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 up. Well, if I continue up, and I just go on and on and on, I never reach there because the arrow tells us we're going, our function value is going to infinity as our x value goes to, well, I continue left, and that's how I continue up. Left in my x direction is a negative infinity. So, I don't like the way that looks. Let's do that a little bit better. So my function value is going to infinity as my x value is going to negative infinity. That's reading from the left, but we also have to continue. Now, my function value is still going up as my x is continuing to infinity. And if you look, both ends of my graph are going up to infinity. Both ends of the graph are going up to infinity. Now, this end on the left is going up as x is going to negative infinity. This end on the right is going up as x is going to positive infinity. So this is how you describe the end behavior of this particular graph. Now I'm going to go back. I'm going to talk about our even functions, link that in. This is an even function. Both of the ends are going in the same direction. Since it's up, my leading coefficient is positive. And again, they didn't ask us to identify if it was an odd or even, or they didn't tell us to identify if the leading coefficient is positive or negative. But I did that just to link in, hey, we have the end behaviors going up, so we have an even function because they're both going in the same direction, not just that it's going up, in the same direction. So we have an even function. Since they're both going up, the leading coefficient is positive. Okay? So now I'm going to scroll over. I'm going to have to erase this. I'm going to have to scroll over, and I'm going to talk about this next function right here. This next function we've already determined is an odd function. If I link in what we know from yesterday, we know it's an odd function because my ends are going in separate directions. Since on the left, my end is going up, and on the right, it's going down, I know that it's an odd function, and my leading coefficient is negative. And again, I'm just linking in what we learned yesterday. Now, to specifically describe the end behavior, again, we're using arrow notation, and that's what you're supposed to use, and that's how, and we can also do that using a Google insert equation. We have our arrow, okay? Now, to describe the end behavior, I'm still talking about my function value. My function value on the left continues up. My function value is going to infinity, as my x value is going to negative infinity, because this is left, okay? So my function value is going to infinity, okay? I'm going up and up and up as I go left, 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 left. Now, in the same instance, I have to talk about the right-hand side. My function value is going to negative infinity because I'm going down, 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 as my x value goes to positive infinity. And all we're doing is reading the end behavior of the graphs. This black information is we're just linking in how to determine if they're odd or even functions and if the leading coefficient is positive or negative. So we'll do a couple of more. We'll continue to link in what we learned yesterday, okay? Let's look at number 4. Whoa, maybe not. There we go. We're gonna look at number 4 next. If I look at number 4, again, I'm just describing the end behavior. Now, well, I guess can't go that far over. I'm describing the end behavior. Now, since both of my ends link in yesterday, since both of my ends are going the same direction, this is an even function. And also, since both of my ends are going down, not up, down, my leading coefficient is negative, F-F-I-C-I-N-T. And like I said, this information written in black is our link to what we learned yesterday. So this is an even function, the leading coefficient is negative. So now we're going to describe the end behavior. So again, I'm reading left to right, okay? I will do this in green. So my function value, okay? In other words, my output, my y values, I'm going down, 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 down. My function value is going to negative infinity as, oh look, my x is also going to negative infinity, as my x values go to negative infinity. So that's from the left. Now from the right, my function value is still going to the negative infinity, but my x values are going to positive infinity. So f of x is still going to negative infinity as x goes to positive infinity. Okay? And again, this is arrow notation. This is the notation that you will be using. Okay? So we're going to do one more. Okay. Let's see. I want to do, let's do this one. Let's do number 10. Okay, number 10 is slightly different. Okay, now again, our ends are going in separate directions. So because they're going in separate directions, this is an odd function. Now, the leading coefficient, is it positive or negative? Well, since my right side is going up in a positive direction, right is considered positive, left is considered negative. Since my right is considered positive going up, and my left is considered negative and it's going down, so they correspond, my leading coefficient is positive. We don't know what it is, that's not relevant. They didn't ask us what it was. Okay, so this is an odd function, leading coefficient is positive. Again, this is a link to what we learned yesterday. Now, today, describing the end behavior, and like I said, we're using arrow notation. So, we're describing it using arrow notation. So, from left to right, my function value on the left, my output on the left-hand side is plummeting downward, so I'm going to negative infinity. As my x values are going to negative infinity. My x values get smaller, so does my output. Okay. Now, as I'm going to the right, my output gets larger. I'm going to positive infinity. So f of x is going to positive infinity as x goes to positive infinity. So we have hit on every type of end behavior, describing them that we're going to encounter at this time. And all we're doing is looking at the end behavior. Where is this function going as at the same time what is happening to my x values? So you're gonna have some practice problems, and let me know if you have any questions. You know how to reach me on Remind. Thank you.